In the first statistics lecture, we talked about what statistics was, why it was important to be statistically literate, and then we focused on inferential statistics and talked about how it was that mathematicians and statisticians figured out how to make inferences from samples to populations, where those inferences can be highly reliable and minimize epistemic risk, and they can also be manipulated, changed to control for or manage the amount of risk that we're taking in any particular inference. In this lecture, we're going to turn our attention to the other area of statistics, the one that the text focuses on much more exclusively, namely descriptive statistics. We'll start off by talking about measures of central tendency or average. We'll talk about the mean, the median, and the mode. Then we'll turn our attention to measures of dispersion, that is, measures of how spread out or compact the data is. We'll talk about range, variance, and standard deviation. Next, we'll turn our attention to graphical data presentation, and sort of specifically the ways in which graphical data presentation can mislead or go wrong. And finally, we will finish by looking at reasoning with percentages. Again, looking at ways in which people, if they're not careful, can fall into mistakes or be subject to improper reasoning based upon percentages. So in the last lecture, we talked about inferring frequencies in a population from our sample. What if we want to look at some data and discuss a predicted general trend, or see how individuals look compared to one another, or how one group compares to another group, so on? These tests all involve what I call descriptive statistics. So for instance, when comparing an individual or group to others, or when looking for a general trend, one seeks to understand the shape of the data and the individual or group's place therein. Now, two measures give one a sense of the overall shape of the data and the relationship between individuals and groups and the population overall. Those two measures are the average, or measures of central tendency, and the dispersion, or measures of how clustered together or spread out the data values are. So in effect, this is what we're trying to do when we're looking at descriptive statistics, at least part of what we're trying to do. You might wonder, well, what is the difference between the average or central tendency and the dispersion? Well, let's start with that notion of central tendency. Remember, this is Christian Huygens. He's the scientist and mathematician who wrote On Reasoning in Games of Chance in 1657, in which he discusses expected value, a measure of central tendency. So let's start with measures of average or central tendency. The average gives one information about the center of the data, the central tendency. Comparing individuals relative to the average often provides one with useful information, descriptions of trends, relationships between individuals, or individuals and groups, or between groups. Now, there are three measures of average: the mean, the median, and the mode, and they each have their way of picking out the central tendency that is useful for some things. So let's start with the mean. Suppose you're trying to plan your studying for the end of the term and you want to estimate how much time you should plan to spend studying critical thinking each day based upon your daily studying pattern during the term. Now, someone like Huygens would suggest that you calculate the mean or the numerical average. You calculate the mean by adding all of the values together and then dividing by the total number of values or data points. The mean is a useful measure of central tendency in those cases where individual variance is limited or when it's not relevant to the assessment of the population. In particular, outliers, high or low or unusual values, can dramatically influence the mean in ways that isn't always good. So let's look at that example of trying to calculate how much time you should spend each day studying. So suppose you look and you decide that, hey, Mondays I would study about an hour, Tuesday 1.2, Wednesday 1, Thursday 1.3, Friday 0.9, Saturday 1.1, and Sunday 0.7. You add those values together and you get a total of 7.2 hours. You divide that by the total number of data points or values, and you get 7.2 divided by 7, or approximately 1.03 hours. Of course, people don't usually study for exactly 1.03 hours. 0.03 of an hour isn't something people usually have on their clock. And indeed, the mean is often not an actual data value. Sometimes it's not a real value at all. For instance, the mean size of families in 2017 was 2.54. Now, that doesn't mean that there were a bunch of family portraits that look like this, Solomon-esque, where the baby's kind of cut in half. No, the average was not a real value for members of families. Likewise, an outlier, a large or low number, like a marathon cramming session the Sunday before a particularly hard test, or taking a Thursday off because you felt sick. These outliers or extreme values will distort the mean significantly, pulling it towards that outlier in ways that may not be useful. So for instance, suppose you have that 7-hour Sunday study session, but all the other times are the same for you. Now your total is 13.5 hours. 13.5 divided by 7 nearly doubles the amount of time you would supposedly spend each day studying because of that single outlier value. Similarly, that Thursday you took off will lower your total hours for the weeks at 5.9 hours. Divided by 7 gives you approximately 0.82 hours, and so now you're studying less each day than you did for every day but your sick day and your Sunday. So outliers can dramatically affect the mean, pulling it towards one outlier or another. So variability is problematic sometimes when we have means. In the next module, we'll turn our attention to our second measure of central tendency, the median.